Okay, so our goal for today is going to be to derive a second method for determining the average velocity of an accelerating object over a given period of time. We already kind of learned about average velocity when we were in the acceleration lab. That was one of the lessons that you did working up to writing your lab report. Um, and so we're going to kind of review that method, and then we're going to sort of learn some different methods. So you're going to learn the formula for the average velocity of an accelerating object, and then you're going to use the formula to find the average velocities of various accelerating objects. Okay, so recall that the average velocity of an acceleration, let me start over. Recall that the average velocity of an accelerating object can be found by calculating the slope between 2 points on the position versus time graph of that object. That's how we did it before. Today we will learn an alternative formula to calculate the average velocity from the initial and final velocities of an object. So you can actually use the initial and final velocity to figure out what the average velocity of an object is over a given period of acceleration. And so let's just sort of review how we found average velocity before. We would take 1 point, right? So this point was at 0 seconds and 0 meters, and then another point, 4 seconds and 16 meters, and then we use the rise over run to find the slope between those 2 points. So 16 meters minus 0 meters equals 16 meters. 4 seconds minus 0 seconds equals 4 seconds. And so then when we take 16 meters divided by 4 seconds, we get 4 meters per second. So our answer is the average velocity of the object was 4 meters per second over the first 4 seconds. Okay, this should be reviewed though, right? We already did this exact problem one time before. We're going to show you actually 2 different ways that we can calculate the average velocity here. And so the first thing we need to do is write our velocity versus time equation. So for this graph right here, the blue graph, the equation that models that is, I'm giving it to you right here. X equals 1 meter per second squared times time squared plus 0 meters per second time plus 0 meters. Okay, and so then the velocity versus time equation for this one would be v equals 2 meters per second times time plus 0 meters per second. So that's coming from, we're doubling the acceleration. So 1 times 2 is 2. And then the initial velocity is 0. Okay, so the velocity at 0 seconds, I'm just going to plug in 0 for time and calculate v. So v equals 2 meters per second times 0 seconds plus 0 meters per second. Multiply that out, we should get that v equals 0 meters per second, right? And so we didn't really need to even calculate that, right? We knew the initial velocity was 0 meters per second, but this is just for reference. Okay, and so then the velocity at 4 seconds, we're going to do the exact same thing, except now we're going to put in 4 seconds for the time. 2 times 4 is 8, plus 0 is going to be 8. So the final velocity is going to be it's going to be 8 meters per second. So the initial velocity was 0 meters per second. The final velocity was 8 meters per second. Well, how does the average velocity compare to the initial and final velocities? That's sort of the pattern that's going to help us figure out this formula. Well, if we look, the average velocity was 8 meters per second. The initial velocity was 0. The final velocity was 8. So how does 4 compare to 0 and 8? Well, what you should notice is that it's exactly halfway in between. It's the midpoint. It is the midpoint between the initial and final velocities. And so we're going to, if you remember from math, the midpoint formula. If not, that's okay. I'm going to teach it to you. But essentially, we can use the midpoint formula to find the average velocity. All right, so now go back and calculate the velocity for the time halfway in between the initial and final velocities on example 1b. How does this compare to the actual velocity? Oh, sorry, this should say average velocity. In fact, I'm going to go and fix that right now. Okay, so let's try that again. So now go back and calculate the velocity for the time halfway between the initial and final velocities. On example 1b, how does this velocity compare to the average velocity? So for this one, again, 2 seconds is going to be halfway between 0 and 4 seconds. So we're going to calculate the velocity at 2 seconds. So we're going to plug in 2 seconds into our formula. 2 times 2 is 4, plus 0 is 4. Our final velocity is 4 meters per second. Well, we should see that that's exactly equal to our average velocity, right, which was also 4 meters per second. So kind of what we should have learned here is 3 different ways to calculate the average velocity. We can do it from slope, which we already knew. We could find the midpoint between the initial and final velocity, right? So calculate the initial velocity, calculate the final velocity, find the average or the midpoint between those two velocities. Or we could plug the time in between the beginning and end of our acceleration and plug that into our velocity formula. And so we'll go through an example of this in a little bit here, but first I want you to take some more notes. The average velocity of an object with constant acceleration is the midpoint between the initial and final velocity. So here's sort of like the formula for that. It's going to be average velocity equals the final velocity plus the initial velocity divided by 2. So really we're just averaging the final initial velocity. Well, that should make sense. It's called the average velocity, so it should be the average of the final initial velocity. The average velocity can also be found by finding the velocity at the halfway point of the acceleration, right? And so that's sort of what we did right here is we plugged in 2 seconds, so that's halfway in between 0 seconds and 4 seconds. Plug that into the velocity formula, and we also found the average velocity that way. So we're going to get some practice with all 3 methods today. First, let's just sort of update our formulas. I think this will be the last formula that you'll learn for this unit, but we're kind of at 4 now, and so I want you to sort of, get some practice with all of them. We're going to use pretty much all of them today. I want you to sort of write them down, and this won't be the last time that you do that. I want you to know all these going into the test. So position versus time, that's good. X equals 1/2 AT squared plus VIT plus XI. This is sort of the first formula that I gave you in this unit. And so hopefully this looks familiar by now. And you'll get a little bit more practice with this before the test. Velocity versus time, V equals AT plus VI. We've seen that one a few times now. Acceleration formula, we learned this one last time. It's acceleration equals V final minus V initial divided by T. Really, that's just an algebra manipulation of the velocity versus time formula. And if we think of V as actually being V final, we subtract VI over and then divide by T. We're actually just going to end up with this formula right here. So these two are actually the same formula. So maybe you don't need to memorize them both. Maybe just the one in the top right here would suffice. But I would write them both down just for clarity's sake. I think this one will be useful at times. And then the average velocity formula, that's the new one that you learned today. Average velocity, or average V, is going to equal V final plus V initial divided by 2. Okay, so let's go through an example. Chloe was roller skating down the street. She was rolling along at 11 meters per second when she started to accelerate down a hill for 8 seconds at a constant rate of 0.75 meters per second per second. How fast was Chloe going when she reached the bottom of the hill? So we're going to use the formula from our last lesson. Acceleration equals V final minus V initial divided by T. Okay, and so then let's sort of identify some of the things that we know. Well, we know her initial velocity, right? That's 11 meters per second. We know the time, that was 8 seconds. And we know her acceleration, that's 0.75 meters per second per second. So then we're going to solve for V final. So the acceleration is 0.75, V initial is 11, and the time was 8. Next thing we're going to do is we're going to multiply both sides of this equation by 8. So that will give us 6 equals v final minus 11. And then we're going to add 11 to both sides. So we should get that v final is 17 meters per second. Okay, and then in example 2b, I ask you to calculate Chloe's average velocity, and we're going to do this 3 different ways. Okay, so the first way is we're going to use the new formula that we learned. Average velocity equals v final plus v initial divided by 2. Okay, so her final velocity was 17. We calculated that on the last page, right? 17 meters per second. Her initial velocity was 11. We gave that in the problem, and then we're going to divide that by 2. 17 plus 11 is 28, divided by 2 is 14. And then remember, your units for velocity are meters per second. Okay, so that's the first way. Second way is we're going to use this formula. Velocity equals acceleration times time plus vi. Right. We know that the acceleration was 0.75. That was given in the problem. Same thing with the initial velocity. That was 11, also given in the problem. For the time, it took her 8 seconds to get to the bottom of the hill. So to get the average velocity, we're just going to find the velocity at the midpoint. So the midpoint between 0 and 8 is going to be 4 seconds. So we're going to put 4 seconds in for time. When we multiply that out, we should get a final velocity of 14 meters per second. Same one that we got up above. Okay, then the last method is the one that you already knew coming into this lesson. That was finding it using slope. So remember, slope is rise over run, and it's the slope of the position versus time curve. So this is the position versus time formula. So we're going to find the change in position over the change in time, right? Because that'll be the rise over run. So we need the position at the beginning and the position at the end. So to get so this is our formula for Chloe roller skating down that hill. For the position at the beginning, we're going to plug in 0 for time. Right? And so then that will end up equaling 0 meters. Right? When we put in 0 for time, because it'll be 0 plus 0 plus 0. Now keep in mind, the way that I got that her initial position was 0 was I just picked that it was 0. It's not actually given in the problem. If I don't give you the initial position, you can just assume that that's 0. Otherwise, the initial position will be given in the problem, and we'll sort of see that in the practice problem for this one. I actually give you the initial position, but otherwise you can just assume that it's 0. And then for the acceleration, I forgot to talk about this. Here, let's just go back a couple slides. For the acceleration, that's just, remember that this value is actually half the acceleration. So instead of putting in 0.75 like I did before, I divided that number in half, and that's what number I'm writing right here. For initial velocity, that's 11. Okay, and so then we're plugging in 0 for time, 0 for time. And so this just ends up being 0 plus 0 plus 0. So the starting position is going to be 0 meters. Well, we already knew that because we put in 0 right here. Okay, so that's easy. Let's figure out what Chloe's ending position was. So we're going to use the same formula, but now we're going to put in 8 for time instead of 0. And so when we do that, and you probably want to use a calculator for this, you should end up with 112 meters. Okay, and so then again, now we're going to calculate the slope using rise over run. So her rise, what was her change in position? Well, that's going to be 112 minus 0. Her run, that's her change in time. That's just going to be 8 minus 0. 112 divided by 8 will end up equaling 14 meters per second. So we got the same answer a different way. And so those are kind of going to be the 3 different ways that we could calculate Chloe's average velocity. We can do it from the average velocity formula. We can do it from the velocity versus time formula by using the midpoint. And then we can do it using her slope between her